Hello everyone, this is Dr. K. Jagannayaki, Professor in MBA Department, Institute of Aeronautical Engineering, Dundigal. So today's topic is hypothesis testing. So if you want to carry out any research study, so initially we have to come out with an hypothesis. So hypothesis is like an assumption, it is a proposition that has to be tested. So hypothesis is usually considered as the principal instrument in research. Its main function is to suggest the new experiments, observations. So the end result of hypothesis testing is nothing but people will come out with a new concepts, new theories, new solution to the existing problems. So in fact, many experiments are carried out with the deliberate objective of testing the hypothesis. So especially when you're talking about the social science research, where the direct knowledge of population parameters is rare. So hypothesis testing is often used strategy for deciding whether a sample data offer such support for a hypothesis that generalization can be made. So if you want to define hypothesis in simple terms, it is a mere assumption or some supposition to be proved or disproved. For a researcher, hypothesis is a formal question that he intends to resolve. It may be defined as a proposition or a set of propositions set forth as an explanation for the occurrence of some specified group of phenomena, either asserted merely as a provisional conjecture to guide some investigation or accepted as highly probable in the light of established facts. It is a predictive statement capable of being tested by scientific methods that relates an independent variable to some dependent variable. So whenever we are taking any problem, so we are going to consider two variables or two attributes. So to know out of two variables, there will be one independent and another dependent variable. For example, consider the statements like students who receive counseling will show a greater increase in creativity than students not receiving counseling. And second, if you take another example, the automobile A is performing as well as automobile B. So these are hypotheses capable of being objectively verified and tested. So thus we may conclude that a hypothesis states what we are looking for, and it is a proposition which can be put to a test to determine its validity. So, what kind of characteristics should a hypothesis consist of? Hypothesis should be clear and precise. It should be capable of being tested. Should state relationship between variables if it happens to be a relational hypothesis, and should be limited in scope and must be specific and stated as far as possible in most simple terms so that the same is easily understandable by all concerned. It should be consistent with most known facts and should be amenable to testing within a reasonable time and must explain the facts that gave rise to the need for explanation. It must actually explain what it claims to explain. It should have empirical reference. The basic concepts concerning to testing of hypothesis are null hypothesis and alternative hypothesis. The word null means nullification, zero. There is no relation no association, like that we used to specify. So which is most probably used in statistical testing. And the null hypothesis is a test always predicts no effect, no relationship between variables, while the alternative hypothesis states that research prediction of an effect or relationship. The null and alternative hypothesis are two competing claims that the researchers weigh evidence for and against using a statistical test. Null hypothesis denoted as H0. For example, if you want to say null hypothesis, it is meant for population, so there is no effect in the population. Whereas alternative hypothesis states that there is an effect in the population. So the effect is usually the effect of the independent variable on the dependent variable. And alternative hypothesis denoted as HA or H1 is the other answer to the research question. So it claims that there is an effect in the population. It is a claim that you expect or hope will be true. The alternative hypothesis is the complement to the null hypothesis. Null and alternative hypotheses are mutually exhaustive, meaning together they cover every possible outcome. They are also mutually exclusive, meaning that only one can be true at a time. So you cannot state that both null and alternative hypotheses are true. So either any one of them is the true statement. So the similarities and differences or dissimilarities between null and alternative hypothesis. The basis for these similarities and differences. The first basis is definition. So null hypothesis defined as a claim that there is no effect in the population. But whereas alternative hypothesis states it is a claim that there is an effect in the population. Null hypothesis is also known as H0, whereas alternative hypothesis states as HA or H1. And what kind of phrases we are going to use to formulate null hypothesis? No effect, no difference, no relationship, no change, does not increase, does not decrease, like that. Whereas the same phrases, while using alternative hypothesis, they become an effect, a difference, a relationship, a change, increase or decreases. The symbols used in null hypothesis are equal to, greater than or equal to, less than or equal to, and all equality symbols. Whereas coming to alternative hypothesis, the symbols not equal to, less than or greater than. The samples P is less than alpha is what we have to do here, means we have to reject the null hypothesis, whereas the same if P is less than the level of significance, then we have to support alternative hypothesis. It means that we have to accept alternative hypothesis. When P greater than level of significance or alpha, then we have to accept H0, whereas the same in case of HA, we have to reject HA. A null hypothesis is a statement about a population parameter. So population parameter we are going to denote with the letter mu, and the test is used to decide whether or not to accept the hypothesis. A null hypothesis defined by the symbol H0 is always one of status quo or no difference. If the null hypothesis is false, something else must be true. So in view of this possibility, Whenever a null hypothesis is specified, an alternative hypothesis defined by the symbol H1 or HA must also be specified. It is the opposite of the null hypothesis. It should be clear that both null and alternative hypothesis cannot be true and only one of them must be true. When we are involved in such an exercise, conclusion must result into the acceptance of one hypothesis and the rejection of the other. The next one is the level of significance. So level of significance, it tells us what is the maximum value of the probability of rejecting a true H0 and is usually determined in advance before testing the hypothesis, and it is denoted as alpha. This is a very important concept in the context of hypothesis testing. It is always some percentage, usually we'll consider 1%, 5% or 10% level of significance at which we used to reject H0 when it is true. So this alpha is also known as type 1 error in hypothesis testing. A significant level of say 1% implies that there is a risk of being wrong in accepting or rejecting the hypothesis on 1 out of every 100 occasions. Thus, a 1% significance level, it provides greater confidence to the decision than a 5% significance level. Then comes decision rule or test hypothesis. So given a hypothesis H0 and alternative hypothesis HA, we make a rule which is known as decision rule, according to which we accept or reject H0 or HA. Then comes type 1 and type 2 errors. So in the context of testing hypothesis, there are basically two types of errors we can make. One is type 1, another one is type 2 error. So in general, accept H0 when it is true. This is correct decision. Reject H0 when it is false. This is also correct decision. But some cases we used to accept H0 when it is false and reject H0 when it is true. When it is true. So this is type 1 error which is denoted as alpha, and this is type 2 error which is denoted as beta. So if you see the table, that gives a clear picture of type 1 and type 2 errors and what is the correct decision. Accept H0 when it is true, correct decision. Reject H0 when it is true. That leads to type 1 error. Accept H0 when it is false. It is known as type 2 error which is denoted as beta error. Reject H0 when it is false, then that is correct decision. So one should remember this type 1 and type 2 errors in the research study on the basis of the level of significance, at what confidence you are going to accept a false H0. And two-tailed and one-tailed test. A two-tailed test rejects the null hypothesis if, say, the sample mean is significantly higher or lower than the hypothesized value of the mean of the population. So such a test is appropriate when the null hypothesis is some specified value and the alternative hypothesis is a value not equal to the specified value of the null hypothesis. So symbolically, we used to mention H naught, mu greater than mu H naught, or mu less than mu H naught in alternative hypothesis. But whereas in case of a two-tailed test, there are two rejection reasons on each tile of the curve which can be illustrated as given below. For example, if your H naught is mu is equal to 100 kgs. So this is the population mean is 100 kgs, but we don't know whether it is right or wrong. If you are saying the alternative hypothesis mu is not equal to 100 kgs. So on a normal distribution curve, the rejection region fall on two sides of the normal distribution curve, alpha by 2, alpha by 2. So this is known as two-tailed test. Two-tailed test. But whereas if you can able to specify clearly mu greater than 100 kgs, then in that case only one side of the normal distribution curve will have the rejection region. Let us take alpha is equal to 1% level of significance. So this is known as one-tailed test, one-tailed right-tailed test. But the same thing, if you are going to specify mu is less than 100 kgs, then the rejection region may fall on the left-hand side of the normal distribution curve. So this is known as one-tailed left-tailed test. So it depends on the symbol in the alternative hypothesis. Basing on that, we can decide what type of test it is, whether it is one-tailed or two-tailed test. Then selecting a significance level, the hypotheses are tested on a predetermined level of significance and as such, the same should be specified. So generally, either 5%, 1% level is adapted for the purpose. The factors that affect the level of significance are the magnitude of the difference between sample means, the size of the sample, the variability of measurements within the samples, and whether the hypothesis is directional or non-directional. So in brief, the level of significance must be adequate in the context of the purpose or the nature of inquiry. Then deciding the distribution to use. After deciding the level of significance, the next step in hypothesis testing is to determine the appropriate sampling distribution. So the choice generally remains between normal distribution and the t-distribution. The rules for selecting the correct distribution are similar to those which we have stated in the hypothesis testing estimation. Selecting a random sample and computing an appropriate value. So another step is to select a random sample or samples and compute an appropriate value from the sample data concerning the test statistic utilizing the relevant distribution. So it is not possible if you have a large number of respondents, the population size is infinite. In that case, you may not consider the complete enumeration. It is better to go with a sample. So draw a sample to furnish empirical data. Next, calculation of the probability. One has then to calculate the probability that the sample result would diverge as widely as it has from experiences if the null hypothesis were in fact true. So here it is always better to go with samples rather than the complete enumeration. Then comparing the probability. If the calculated probability is equal to or smaller than level of significance in case of one-tailed test, then in case of two-tailed test, it should be distributed equally on the two tails of the normal distribution curve as alpha by 2 and alpha by 2. Then reject the null hypothesis and accept the alternative hypothesis. But if the calculated probability is greater than the critical value, then accept null hypothesis. In case we reject H0, we run a risk of committing type 1 error. But if we accept H0, then we run some risk. The size of which cannot be specified as long as H0 happens to be vague rather than specific, then we used to commit type 2 error. The flow diagram for hypothesis testing involves the following steps. So first, identify the problem. Basing on that, formulate the hypothesis. Formulation of hypothesis includes H0 and HA, null hypothesis and alternative hypothesis, and specifying the level of significance, which is denoted as alpha. So in general, we may go with 1% or 5% level of significance, which tells us about the confidence interval out of which you are going to reject a true null hypothesis. Then decide the correct sampling distribution. So in this case, whether would you like to go with random sampling technique or non-random? So sample a random sample and work out appropriate value from the sample data. Then choose the appropriate test statistic based on the distribution, what type of data it is, whether it is normally distributed or the given data follows t distribution, chi-square distribution, f distribution, and so on. Compute the test statistic, compare calculated value with the critical value, and basing on that, we have to make the decision either accept or rejection of hypothesis. So coming to the first one, for example, you want to find out define H0. There is no significant difference between IQ levels of male and female students. So you have given a sample size of n is equal to 28 students. And you have given sample mean 20 and population mean is 40. N is equal to 20 students. X bar is equal to sample mean is equal to 25 and population mean is 30 and standard deviation is 10. Standard deviation is 10. So this data is available and we have to test whether there is significant difference between male and female students with reference to their IQ levels. So since the sample size is less than 30 and the given data is normally distributed, we have given sample mean, population mean and sample standard deviation. So apply t-test. So t is equal to x bar minus mu by standard deviation divided by root n. So these data we have to insert in the formula and find out the test statistics at 5% level of significance. What will be the critical value, and then we have to compare and make the decision. Like how we used to test the hypothesis, and basing on that we have to accept or reject null hypothesis. So hypothesis testing is one of the basic concept in any kind of research studies, and most probably if the research is related to qualitative research where we are going to study the behaviors, attributes, and you want to describe something. So there we are going to formulate hypothesis, both null and alternative hypothesis, specify what type of test it is, whether it is one tile or two tile, and what is type 1 and type 2 error, and finally use appropriate statistical test, compare the results, and make a decision. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.